Thank you very much for coming to my talk. And today we're going to talk about how to upgrade your Linux kernel. Okay, a little bit about myself. I do Linux at Cloudflare. I enjoy system security and performance. And I'm passionate about low-level programming, so Linux kernel drivers, bootloaders, and other stuff written in scary, unsafe languages like C. I'm also a die-hard Linux fan. That's why I'm presenting from a Mac. But if seriously, this conference has sustainability theme, and I was also wondering, like, there was some information on Twitter that Microsoft is deprecating Windows 10. It will send a bunch of computers to landfill, and I'm happily running like a modern Linux distribution on my home laptop, which is like 15 years old. So Linux is great, except when it's not. We don't have a lot of people here, and I can't see, but what would you do in this case? Imagine if you're working and doing your stuff, and suddenly a pop-up appears that updates are available. Who would press Install Now button? Yes, good. Who will remind me later? Yeah. Okay. Anyone different here if it was a production system? So yeah, for production systems, when we get an update, they do either remind me later or disable updates completely. And that's natural because this is related to how we perceive software updates, right? So, and we don't perceive them really well. So software updates are not good because they kind of introduce instability into our workflow. Why touch it if it works, right? But with regular software updates, they're kind of these monsters, but they're not like scary monsters. They're more like ugly, annoying monsters. But when it comes to Linux kernel upgrades, usually it's a different type of monster because it kind of can destroy all your universe. And again, this is natural because we, as software engineers, we know how to deal with regular software updates, even if our service like crashes once in a while. We're all professionals. We can just use systemd and tell it to restart it, and our job is done, right? Yeah, we will be operating in degraded mode, but it's not the end of the world. On the other hand, when Linux kernel crashes in production, you don't have anything. You don't have your systemd to save you. You don't have any metrics monitoring, like the machine becomes completely unreachable. And this is basically what like SREs are starting to look like when it happens. So that's why people avoid upgrading Linux kernels, like with all their heart and soul, right? But there are some risks if you don't apply your Linux kernel upgrades regularly. And the first one is like basically if you don't upgrade your kernel, your bugs are not getting fixed. And to mean by that, here is some statistics. So this graph shows you number of commits on a 6.1 stable branch. I will be talking about Linux kernel releases later, but these releases, they are bug fix releases. So like these releases are released roughly every week, and they only fix bugs or security vulnerabilities. So as you can see, on a 6.1 stable branch, there were so far there were 77 releases since yesterday, and 51 of them contains more than 100 commits, meaning more than 100 bug fixes. 21 is 200 commits, and there are these 5 mega releases with more than 500 bug fixes in a single release. And if you look at the graph, it's actually 7-ish, but the last two didn't make it to 500 mark. So for the clarity of data, we'll stick with it. If you don't apply updates regularly, you're missing out the various performance improvements. So this is an example from Cloudflare production systems when we started evaluating to migrate from 5.4 kernel to 5.10. So this is before and this is the average server memory consumptions before and after. And as you can see, like at first did we break anything? But turned out it's just like in 5.10, there was a major rewrite in the memory management subsystem, and it kind of saved us 4.5 gigabyte of RAM per server. And if you're running a big distributed network or you're paying for your cloud, you know how much of a 5 gig of RAM per server might cost you. Yeah, and we did nothing to get it, actually. Like, we just upgraded the kernel, but the work was done by other people in the community, in this case, engineers from Facebook and Meta, and we just leveraged their work, we benefited from it. Right. Now let's talk about change delta. This is kind of the same data of number commits per release, but it's now in a cumulative view. So like each bar shows you number of commits since the release 0. And in this case, you can calculate so-called change delta. Now imagine you wanted to, at some point, and again, remember these bug fix releases are released roughly every week. So imagine you want to upgrade from 6.110 kernel to 6.120. So you kind of want to pull in 10 weeks of updates, right? So, and your change delta will be roughly like 1,762 commits, right? Now, let's assume that like the number of commits you're pulling are somehow, which is reasonable to do, somehow proportionate to risk you are taking. So you're taking 1,700 and something changes, so this is somehow designates your risk, right, of like the systems being unstable or actually these bugs being able to creep up. Now, if you, for some reason, let's say you, for whatever reason, you decided to delay the upgrade by 10 weeks more, and now you're upgrading from 6.110 to 6.130, and your change delta is different, it's 3,910 commits, and you might have think that, like, okay, your original update was for 10 weeks, now you're doing for 20 weeks, so probably your risk is like grew twice, but not the in this case, sometimes it's not the case. If you calculate the difference between the commits, you might see that even that for 2x delay of not upgrading, you your risk grew faster in this case, so it kind of 2.2, you get 2.2 more risk of not pulling in the bug fixes. Security, if you don't pull in updates, the vulnerabilities are not getting fixed. So this is kind of a similar graph, but it shows only the number of publicly known CVEs patched in a single bug fix release every week. And again, to show you some perspective, out of 76 releases for the data was available, 61, like almost every release has at least one CVE patched. And like there is like 19 releases, like 20-ish% or even 25-ish, right? So like more than 5 publicly known vulnerabilities patched in the Linux kernel. And again, this data is crowdsourced, so it might not be complete. So it's a minimum baseline version of your getting. By not patching vulnerabilities, you may also risk your compliance. If, for example, you're doing like payments or something and you're subject to PCI DSS compliance, you may find this requirement that a known security vulnerability in a critical system needs to be patched within 30 days. So it means like rolling out a new kernel to all your production within 30 days. Who here heard what happened to Equifax? I mean, it wasn't regarded. They had like a breach because they didn't update their software. It wasn't the Linux kernel, it was the Apache software, but the thing is the same. So if you don't patch your software, attacker knows that you have a known vulnerability running in your system, and they will try to exploit it eventually. Which brings us, not so fun fact, that like in 2000 there were these old popular sysadmin forums where people boasted how much uptime their server has, and like the more uptime you have, the more stable your system is. Like people say, like I have 2 years uptime, 3 years uptime, but now it's not cool anymore. If you boast you have like more than 30 days, most likely you're vulnerable, non-compliant, etc., etc., etc. So it's nothing to be proud of. Which comes us like when we try to update the Linux kernel in production, we usually hit the standard company standard like change process, which usually has the best intentions to introduce change management, but actually turns out to be an anti-pattern for Linux kernel releases for different reasons, just because the kernel is so special. The first thing, when you try to update the kernel or any other software, your change process may ask you, you have to justify that update, like which things from the change log is applicable to your workload. Like, do you need these changes in the first place? Usually commonplace in financial institutions. But the reason it doesn't work with our kernel is because of this data, right? So if you, every week, you need to deal with at least 100 entries in the changelog, and every week you have to go through each changelog and kind of like understand on a really deep technical level if this change is applicable to your workflow. So it's kind of like never works out in practice. So you will be just like blindly stamping the things with no actually real benefit. Similar things can happen with security updates. So yeah, you say we need to patch the kernel because it has a CVE, and then somebody will ask you, is this vulnerability actually exploitable on systems and the workload? And sometimes it's easy to answer because like if it's in a driver and you don't have hardware for it, probably not. But many times it's much more complex than that. And it's probably the right question to ask, except that we're asking it for a wrong person. So who exactly knows if this vulnerability is exploitable on your system? Probably is the attacker, because they're highly motivated to break into your system. This is their bread and butter, and they spend 24/7 trying to design a successful exploit if they know your system is vulnerable to some vulnerability, right? So this is this person who is like really into it. But we don't know who they are, right? So we are not asking the question to the attacker. We ask this question a security professional within our organization who has different priorities. They are highly motivated to go home on time. They probably accept your just reviewing the Linux kernel patches. They need to review many other things, and secure architecture, software design, and many things. And they have other competing priorities. So for this person, like the attention span they can give you to really properly answer this question is like 5 minutes per security vulnerability. And the Linux kernel is just too freakingly complex to understand if like a particular vulnerability is actually exploitable in a particular system. Many change management processes say like, okay, let's just soak the new software somewhere a canary for some time. And usually for kernels, they say like at least 1 month to make sure it's stable. But again, if we go back to our familiar graphs, the more we soak it in canary, the more we delay production release, the more change delta we accumulate, and the more risk we obtain. As well as if we don't release kernels to production soon, our production runs with known security vulnerabilities, which are becoming patched almost every week. And 1 month is usually breaks your compliance, because 30 days is a very typical requirement to roll out a security vulnerability. And if you zoom out and you think like, what does like high soak time probably means? And it probably means you actually don't know what you're looking for. So it may indicate your lack of metrics and observability. And probably you don't know your workload, right? So like my team often get questions, will it break my software? Like, I don't know even what your software does. Is it a database? Does it care about I/O performance? Is it like, like some encryption service which cares about the crypto performance or something like that, you know? So it's probably lack of sufficient pre-production kernel testing as well, unit tests, integration tests, and performance tests for specific subsystem your workload cares about. So if you have these tests, you're kind of more comfortable saying, we don't need these high soak times. This is the behavior I expect from the kernel. My test very validated. It's free to roll out to production. Well, sometimes just people go crazy, say like, yeah, the kernel is just a too critical component. Let's have a different approval process. And we had this in Cloudflare, so regular software release requires 1 approval, but kernel need to have like 2 or 3. And this is again connected with this like bad perception that the kernel is this monster, which is like too scary. But what if I told you that Linux kernel releases are inherently safer than any other software? Would you believe me? So this is a Cloudflare network map. So these dots on the map is like all data centers. So we have a huge data centers around the world. And it comes with and like, how do we release software there, right? So like obviously not manually. So we have systems in place. So how does a regular software update looks like in Cloudflare? So yeah, engineers like build new software package, push it into our internal package repository. Then we have our configuration management system, which continuously applies expected changes to our network. So it will pick up the package and download it, and if it's a service, it will do a service restore, graceful or non-graceful. It depends on the workload, but it doesn't matter. So the gist here is, if you deploy any package and you don't have explicit rail guards for a stage rollout of that package across the network, new bad or good code can propagate to production within minutes. And we unfortunately learned it the hard way. So there are these two links. You can then find them later in the presentation. There's a Cloudflare blog post describing two of our very scary outages, which almost took down the entire network. Linux kernel current, the biggest advantage and probably the curse of the Linux kernel, to update Linux kernel, you need to reboot a system. And basically, reboot is not an easy operation, right? So in Cloudflare, we have automation to reboot a system, and what it does, it drains traffic from the server, takes some time, puts it out of production, does the actual reboot. Then when it comes up, there's some networking happens when it waits to be reconfigured, some acceptance tests are running, and then it's put back into production. And probably we're not, and everyone here is not as crazy not to reboot the whole network at the same time. So obviously we have systems in place. If we need to reboot servers, we're rebooting them one by one or in batches. So in this case, this provides us with an inherently natural slow pace of kernel rollout. So we put the new kernel out there, machines started rebooting slowly, one by one. If something goes wrong, well, yeah, only a couple of machines didn't come up, so we stopped there. We have hit the big red button, roll back the release, and nobody even notices, without any additional guard layers for the deployment process. Many people are afraid of Linux kernel releases because they don't know how kernel releases work, and apparently not all kernel releases are created equal. So kernel version is designated by three numbers, like leftmost, the middle one, and the rightmost number. For example, 6.1.32. And who here is familiar with semantic versioning? Yeah. So remember, this is not a semantic versioning system. And this is where people are mostly confusing this. Is kernel releases do not follow semantic versioning. Instead, what you have is the two leftmost numbers indicate a major version, and not major and minor. So, and the rightmost number indicates a bug fix release, where you can get only bugs and security fixes. And when only the rightmost version increments, you will never get new features, kernel features from major subsystem rewrites. So here's how the development process roughly looks like. So the main kernel code is stored in the Linux mainline branch. It's still handled by this guy, if you know this guy, the benevolent dictator, someone calls him. Even though the kernel is open source and very democratic project, yeah. But the whole development happens in branches, subsystem branches. So there is a branch for drivers, memory management, and net. And occasionally, Linus pulls changes from these branches into his mainline branch. And probably this is where the original pull requests come from, not the fancy GitHub style, but those are actually email, subsystem maintainer emails Linus say, hey, can you please pull from my branch? So this is how pull requests really look like. And occasionally, Linus does a stable release, so he branches out his mainline branch into a stable branch. And this stable release is designated by some number like 6.1, 6.2, 6.3, and it happens roughly every 9 to 10 weeks. And at some point from these branches, a tagged release is being made for a bug fix release, so 6.2.1. So how does actually these branches get bug fix releases in a way that new features are not introduced? So if you encounter a bug in the Linux kernel, you don't submit it directly to a stable branch. You should actually submit it to a respective subsystem developer branch to make sure this bug is not only fixed in stable version, but in the upstream mainline version as well. So you kind of submit your change, your bug fix. It's specially marked, so it eventually travels to the main Linus branch, But from there, it's not merged back to the stable branches. Each stable branch has their own maintainer, and because these commits are marked specially, they basically cherry pick these bug fix commits from the main Linus branch. And eventually, when enough commits are getting accumulated, the stable branch maintainers do another bug fix release, and they roughly happen every week. So yeah, a new major stable kernel version is released every 9 to 10 weeks. And surprisingly, there is only 2 weeks what is called the merge window to merge new features. 7 weeks is still for bug fixing. So there is only 2 weeks at a time where you can introduce new features to the Linux kernel from the whole 9 to 10 weeks. And the leftmost number means nothing. So this is where some people are getting confused. So we had this interesting thing like, oh, we're upgrading. Previously, we upgraded from 4.19 to 4.20. So it was major upgrade, but not as scary. But now we're upgrading to 4.20 to 5.0. That's probably a super mega update. No, Linus increments the leftmost number when he sees fit. And sometimes he tells when he runs out of fingers to count the middle numbers. But for whatever reason, sometimes he does it when at 19, sometimes he does it on 21 and 20, so he has like a variable number of fingers, probably. Yeah. And bug fix and patch releases are released once a week, and they are denoted by the rightmost version number. They're usually cherry-picked from the main Linux branch. There is never new features, therefore regressions are quite rare. And because of the sheer number of bugs and security vulnerabilities, you almost always want to apply them. You don't have to think whether you need them or not. You do. What about major upgrades, right? So usually a stable release branch is active around only 2 to 3 months, and then it's declared end of life. So no bugs and security fixes are then backported to this branch, and it is expected that a new major stable version should be available at this point. But sometimes it's very costly to evaluate a new major kernel release every 2 to 3 months. So therefore, there are special type called long-term stable releases, which have bugs and security fixes being backported for at least 2 years. And it's usually the latest stable release of the year. So therefore, you have a new LTS long-term support release released once a year. And it gives you, provides enough time for you for more rigid evaluation for the next long-term release. So you have this more time. Yeah, and interesting thing, it's all very well documented on the kernel.org site. Okay, this is mostly what I wanted to tell you today about the kernel releasing. So some conclusions is that Linux kernel upgrades are not more risky than any other software. Did I convince you, hopefully? You need to patch early and patch often. And don't create any process around bug fix kernel releases. Bug fix kernel release should be applied with no questions asked. Because of the sheer amount of code in the Linux kernel, there's almost usually always with something applicable to your workflow. If evaluating a new major kernel version is costly, stay on the long-term branch. But do not wait for the whole 2 years. Better start evaluating the new long-term release after year 1. So you still have a lot of reg room to figure out all the bits and pieces with the new major release. Yeah, and kind of understanding your workload, metrics monitoring, and pre-production testing and automation will allow your systems to stay patched and secure, minimize your soak time, and kind of will give you more confidence in the kernel releases. I hope I caught up with time, so thank you very much, and thank you to the sponsors.
Amazing. Let's give a big round of applause. Thank you.